Okay, so let's look at an example. All right, so again, I think some of these are problems from the homework that I actually did assign you, and some of them are problems that I did not. So you might want to just watch the whole thing and then check your homework. So we have the integral of x squared square root of x cubed plus 1 dx. Okay, so it's chain rules. You're looking for the most inside thing to be your u. Okay, so u is going to be x cubed plus 1. So take the derivative of u and you get du. Take the derivative of x cubed plus 1, it would be 3x squared and then dx, all right? But if you look at our problem, it just says x squared, not 3x squared. So you have to get x squared by itself. So you're going to divide by 3 on both sides. So you get x squared dx, and then this becomes 1/3 du, okay? So when you go to substitute back in, it becomes the square root of u, and then this x squared dx becomes the 1/3 du. Okay, so this right here, x squared dx, gets replaced with this. All right, now the great thing about calculus is there's like rules for how to deal with every little thing. So with 1/3, you can actually move it to the outside, okay? It's the constant multiple rule, so if you have k times f of x dx and you're taking the integral of it, you can move the k to the outside, okay? So you should have that in your notes already. All right, so you can move this out, so now it's just the integral of the square root of u du, okay? And I like to rewrite that as u to the 1/2, and then we're going to take the antiderivative of it, so it'd be u to the 3/2 times 2/3 plus c, and then you have a 1/3 out here multiplying by the whole thing. Okay, so 1/3 times 2/3 gives you 2/9, and then you have u to the 3/2. Now you do not have to write the 1/3 times c, okay? C just stands for a constant, so if we had a number there, you'd multiply it, but we're just saying it's a constant still. So 1/3 times c is still just a constant. All right, so then you go back in and you replace the u with our x terms, so u is equal to x cubed plus 1. So it's going to be 2/9 times x cubed plus 1 to the 3/2 plus c, okay? Always go back in and substitute it at the end. All right, you can take the derivative of your answer and you should be able to get this, okay? So you should test this out. Take the derivative of this. If you get this, you did it correctly, okay? All right, so let's do a trig problem because I know you all love trig so much. All right, so we have the integral of secant squared of x times tangent of x plus 3 dx. All right, so it's kind of hard to see what's the inside thing here because there's not really like a bigger function taking control, but this is what you need to think about. This is where you need to know your derivatives because tangent, if you take the derivative of tangent, you're going to get secant squared, so this is going to be your u. So u equals tangent x plus 3, and you take the derivative of that, you get secant squared of x dx, which, what do you know, you've got that in the problem. So you replace this with u du. Okay, so this whole thing became u, secant squared x dx became du. Take the antiderivative of that, you get u squared over 2 plus c, and then you just go back in and replace the u with tangent of x plus 3.